Hello, today I'll be walking you through the implementation of key data structures in Part C and their application in Part D, which manages grid overflow states. So to my left side, it's Part C coding, and Part D coding is on the right side. So let's start with Part C. Here we have three data structures, a stack, a queue, and a deck. Each follows standard principles: last in, first out for stack, first in, first out for queue, and double-ended access for deck. Let's go over them briefly. Stack, this class lets us push and pop items following the LIFO principle. If we reach the stack's capacity, it dynamically doubles to fit new items. Queue, similar to stack, but this time with the FIFO principle, so we add items to the end and remove them from the front. Deck, a double-ended queue where we can add or remove items from both ends. This flexibility makes decks especially versatile for tasks needing both stack and queue functionalities. Now, moving over to Part D, where the structures come into play in managing a grid's overflow states. In Part D, we define two main functions: get flow list identifies get overflow list and overflow. So get overflow list identifies overflow cells in a grid. Each cell has a threshold based on its location, whether it's a corner, edge, or inner cell. This function goes to each cell and checks if the absolute value exceeds its specific threshold. It returns a list of all cells in overflow or none of there are in any. Overflow function manages the redistribution of overflow states across the grid. It starts by checking for any overflow cells. If found, it redistributes the excess to neighboring cells. For example, if a cell overflows, it increases or decreases the value of its neighbors. We store each grid state in the queue with each redistribution step, helping us review how the grid evolved over time. The function stops when no cells are in overflow or all non-zero cells share the same sign. In a sense, Part C's data structures enable efficient handling of grid's dynamic states in Part D. The queue, in particular, stores each grid state after redistribution, making it impossible to track the overflow process step by step. And to wrap this quick overview of the code, thank you.